Hello dear friends, today we will write a program for classifying varieties of iris plant. Let's start with the facts that for whom the classification of iris is needed and where and how iris is used in our time. Certain varieties of iris are needed in medicine. With the help of them, doctors treat quite seriously diseases. Secondly, iris is used in cosmetology. With the help of it they make excellent essential oils, balms, ointments, etc. And the third, as I think the most important, classification of iris may be needed by biologists because they keep a report on different plants around the clock, and if they touch the iris, make sure that species does not die out, or what chance do they indicate about something upcoming is in general, so that the plant does not get into a red book. So let's now get down to the code. First of all, we import pandas as PD. In this case, pandas is necessary for further reading the file from sklearn library from the selection module we need to import. Two functions, train test split and grid search S3. The train test split function in machine learning is needed to divide data into training and test data. We train the model on the training ones and we test it on the test ones. And we use grid search CV to find the best hyperparameters, but more on that later. And the final thing that we need to import is from sklearn imports Cvm. The Cvm model has an SVC class that will help us to train the model. Then we will immediately set the path variable. This will be the full path to my iris as SVC file. Now we'll read this file. The readSysFile function from the pandas model help us to do this. Next, we will create a params variable. This will be the parameters of our data set with which we should predict the name of a particular variety of iris. Here, with the help of such a command, we got all these parameters. Maybe even display those on the screen. These are parameters such as sepal length, sepal width, petal length, and petal width. Next, we will predict our name. This is in our data set what we should predict via our grade. Next, let's immediately divide the data into training and test data using our train and test split function. Pay attention to such a parameter as test size. It is equal to the 0.2. This is 20% of our entire dataset. 80% will be training and 20% will be test. The first parameter specifies our parameters, not names but params, and the second is already data with the index name, what we should predict. And the last parameter is a random state, where we can specify any number of the integer type via a kind of seed, It swaps the rows in our frame data. Before we start training the model, I wanted to introduce you a brief theory about the Cvm algorithm. The main task of the algorithm is to find the most correct line of the hyperplane separating the data into two classes. Cvm is an algorithm that receives data as input and returns such a diving line. Consider the following example. Let's say we have a dataset and we want to classify red squares from blue circles. But find main goal in this task will be to find an ideal line that will divide these two classes. That is, approximately this is what our algorithm does. Now that we know the theory, we can talk about hyperparameters of the OWL class and in general what are hyperparameters in machine learning. Hyperparameters are called algorithm parameters, the value is set before starting the learning process. In this sense, they differ from the usual parameters calculated in the learning process. Hyperparameters are used to equalize the learning process. The S3T itself has two parameters, this is T and the gamma. Hyperparameter T breaks the fine line between the smoothness and fineness of the classification of object training in the sample. The higher value T, the more objects of the sample will be correctly classified. The gamma hyperparameter determines a few far away. Each days over elements in the dataset has an influence in determining the ideal line. The lower the gamma, the more elements even falls that are far enough from the dividing line take part in the selection process in this very line. Now I put this code and explain what is happening. Here, as you can see, the name of hyperparameters of the CVT gamma algorithm and our list of the value from which will take the most optimized our data, or in words of necessary knowledge for prediction. And the variable parameters 1 is just a dictionary from these lists. And now we create variable model in which our model will be stored. And specify the parameters of our variable parameters when we will create a variable grid, where we will use the class grid search CV. The first parameter we need to specify our model, and the second parameter we need to specify our variable parameters 1. And the first parameter we can specify the CV parameter. CV is a cross check that shows that our model has not been trained. And now we can train our variable grid so that it picks up the best hyperparameters. Run the script. And as you can see, it has been trained. Let's now predict the data for the test value. And immediately compare them with the correct answers. For this, we turn pret into a list and compare our variable pret with our variable x test. As you can see, everything is true. Everywhere the values are true. That is, we trained the model so what it will deduce all the values completely. And this is our video has come to an end. All the sources I will upload, you will find the link to your GitHub and a link to in your descriptions. Write in the comments wherever you liked the video.